The second task will be data acquisition in LABVIEW without hardware.
Measurement and Automation Explorer. Choose simulated an IDAQMX device. In the device chooser, expand M-Series DAQ and select PCI 6221, then click OK. After that, we need to test the simulated device. Right-click the new PCI 6221 and choose Test Panel. On the Analog Input tab, ensure channel name is DEV2 or AI0 is selected, mode equal to Phoenix. Rate equal to 1000 Hz, sample to rate equal to 100. After that, go to the LABVIEW and create a blank VI. Place the AQ assistant inside the while loop. Pick the same channel as the one that we put inside the test panel. We need to create a waveform graph beside the DAQ assistant. You also need to add time delay, zero point 0.1 second. Configure the time delay with 0point 0.1 seconds so the loops run every 100 milliseconds. After that, add statistic block. Configure the statistic VI. Statistical calculation must be arithmetic. Mean extreme value must be maximum and minimum. Then we need to create numeric indicators for mean, max, and maximum and minimum. And create control at the stop button too. After we wire everything, Don't forget to save and run the VI. For data logging, we also add write to measurement file. On the block diagram, go to the express and pick output, and you will find write to measurement file. Configure the file path and file format as required. Wire everything, wire the AQ output to the waveform, to the statistic VI, and to the write to measurement file. And here you can see all the data that we got after we add write to measurement file.
Okay, the purpose of this exercise is to build a simple LabVIEW application that acquire a real-time voltage data from a DAQ device and display the signal on a waveform graph, compute basic statistics, and logs the acquired data to a measurement file. So the aim is to learn how to configure data acquisition with the DAQ assistant, visualize time domain data, extract useful numerical summaries using the statistic function, and persist data for later analysis. Now I will explain how the system works. The DAQ system will continuously sample the analog input channel and output a waveform. The waveform is simultaneously fed to the waveform graph for visualization and to the statistic block for numerical processing. Statistic will calculate the arithmetic mean, maximum, and minimum values for the most recent samples buffer and output them to the front panel numeric indicators. Then, the write of measurement file will receive the waveform and save the data to disk for later review. A time delay inside the loop defines how frequently the loop iterates, preventing resource overload and controlling the effective display or logging rate. The loop will run until the stop button is pressed. Okay, for the real world application, we can use this system for many things, many applications. First will be sensor monitoring system, research data acquisition, industrial process monitoring, or even predictive maintenance. Okay, for the sensor monitoring system, we use it to continuously logging and monitoring of temperature, pressure, or even voltage sensor with alarms or threshold aided. Okay, for the industrial process monitoring, we can use it to monitor process variables such as motor voltage, load cell output, and we'll be storing all of these trends for quality controls. Finally, I learned how to configure the DAQ assistant to acquire continuous analog data, how to route that data to a waveform graph for real-time visualization, and even I know how to compute tacit statistics using the statistic block. I also learned how to log data using the write to measurement file function and how to control continuous execution with a while loop and a stop button. To overcome my weakness on this task, I use the quick drop function to search all the new icon or the new function, as it will make it more faster doing this task.